This is another alternative on how to make the chicken jump without any animation. So this is an alternative solution from what the tutorial from Penguin Designs is actually doing. So uh, please look at the Penguin Design tutorial to get the whole uh, Crossy Road uh, making games, and then go here if you want to look at how to make the chicken jump without any animation. Penguin design tutorial is pretty good. I think the top things that I like about the tutorial actually the background music. It felt like I'm playing game there. So let's jump into what how do we able to make this chicken jump without any animation. So if you notice at the last tutorial section for the Crossy Road in Penguin design, he's doing like bug fixes on how to make the movement actually better. And then the way he do it is to cut down the number of animation that he used into just jumping animation. So in this tutorials, which is a continuation from what Penguin Designs comes from, is actually to do the jump completely without any animation. Okay, and that will make this much smoother. So, and also I add a new feature to make the chicken fly. So let's see, let's us demo first what we are going to do, which basically actually, oh, I haven't played this. Let me play. So the behavior that I create here is when even this idle state, I make it by code. There is no animations at all. And then when we press down the key, the chicken will be in a tuck down state. After it is in tuck down state, if we release it, it will jump. Okay, jump, 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 jump. Okay, and then this is the flying skills. So if you try to press the button enough, this becomes almost like Flappy Birds. So if you are interested about how to do this, let's we goes into the code. Most of it are inside the code. Let me stop this first. Let's go to the code. So it will be most of the code, actually all of the code is inside the bounce.cs. Okay, in the bounce.cs script, in the bounce script, we'll make most of the changes in the update. Okay, everything start with the update. So remember the state just now. When we press the button down, which is this if input.get button, we will be doing, the chicken will do tuck down. It will tucking down, right? And as long as we press the button down, it keep tuck down. And then if we release it, which is detected with this input.get button up, we will make the chicken jump. Okay. Otherwise, we will be in idle state. That state where it's going blum blum blum. I don't know how to say it. I think you know. And this part is just to smoothify the state transition there. So one thing that is added here is about the state. So we keep on a state value for the chicken. What is the chicken in? Whether it is in idle, whether it is ready to go back to idle after jumping, or it is in a jumping state. Okay, so those are how we kind of store the state of the chicken. Ideally, we use something like enumeration, but actually I'm not familiar yet with C#, so I'm just doing it quickly using a string. But the idea is the same. You can just Google out how to do enumeration, because when you are serious about this, of course, you want to use the best practice that you can with the C sharp. Now let's continue. So this about the state, and after we decided what to do about the chicken, we do the normal update situations. So there are several things to be updated about the chicken, which is the scaling. The scaling is the one that make the chicken as a longer, lengthen or shorten. When it is tucked down, if you notice, the chicken becomes shortened to simulate the idea of it being tucked down, but actually it's just scaling down the y-axis. And then the update positions is about the positioning state. So when we what do you call it? When we press the button, that it will move up, or if whether it is going to move the XY axis, forward, backward, left, right. Update jump state is about the what you call it? It's a special things to control how it moves in the air. Okay, so let's go first with tuck down. So when this is the first if, when the button press down. So when it is in the initial state, it will be button press down. It will be going to tuck down, and what tuck down doing is actually first it will set the state of the chicken in the tuck down. This is to ensure that it is not going to the idle state, and then we'll start with the current scale time into 0, and start of the scale is actually the scale of the chicken object. Remember, this game object is actually referring to the object that is attached with this bound script, and this bound script is attached to the chicken object, right? To the parent chicken actually. And then what happened is we grab this their initial scale, and the iron scale will be, we are scaling down the y-axis, which means the vertical one. Okay, that's why we keep on the x and z, but we make it shorter. So that is tuck down. That's the essentials of the tuck down. So basically the tuck down functions determining where it starts, where the scale start, and where the scale end. That's what it's changed. So the start scale and end scale are changing, and the current style time is initiated into 0. And this will later on affect it, of course, when we go to the update scale state, where the update scale state is basically the same with any kind of changes. What is different with tuck down and the others is about the end state of it, right? Basically, it starts with the scale percentage, which is starting from the what you call it. Basically, it's using the current scale, and then for its current scale time, it will increasing it based on the scale speed. This is exactly the same with how the penguin design actually making its movement code, right? Movement, I mean, like the scaling code. Basically, we will update the game object transform local scale with the vector 3 alert to make it having a transition movement. And then we pass in the starting scale, the ending scale, and then what percentage of it at the moment. And the scaling speed is, this is just some numbers that we set up in the beginning, and this is to make it sure that we go to 1 whenever it's just reaching greater than 0.8. This is exactly the same with what in the penguin design, but basically we factor it out side of the other things, because there are multiple things that can change the scale. Just now we see the tuck down, that's changing scale. Another thing that changing scale also is the jumping, right? So that's the first if and the first tuck down. Let's go to this one. This is when we release the button. Get button up is when we release the button. we will do jump. Let's see what is jump about. Jump will first of all, it's going to change the state into jumping state, jump state, and then it has a different scale speed. In this case, I'm using 5. This is just tuning. You when you do it yourself, try to get to tune this one to the one that you desired or you felt make the movement of the chicken is a better movement, because that's actually one of the challenging things about action game, is if you can design a great character control. If you ever play action game that is not good, you can feel how bad it is to 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 control character. And then let's go back to the jump again. The jump, what jump is about is it changing two things. It's changing the position and the scale, right? If you remember how the animation is created in the penguin design tutorial, it will do the scaling on the y-axis to make it longer, and also it will move the position of the y-axis higher. So that's how the jumping animation is about. Here we make it into code. Why? Remember what was the problem that make the character control, the chicken control is not good in the penguin design tutorial? Is because the animation actually intercept your control. So when it is in animation, your control, when you change the state into jump, actually not directly being read. It needs to wait for the animation, its animation state to be finished first. So during that animation state, actually your character stuck in that animation. That's why the animation is going to limit the smoothness or the ease of control of your character. Um, that's why if you remember in the beginning when I was just starting, there was another video. I will also link it down below. I have another video about how to make it better, which was try by doing cutting down the number of frames of the animation. But here, this is the best solution. We just don't use any animation at all. So we grab the starting position from the current game object, which is the chicken, and also starting scale value. And this is to initiate, because we just starting to jump, we want to start the scaling movement from 0. Same with the position. Current lap time is going to control the percentage of position from that happening in the chicken. And then the end scale, this is the end scales about. If end scale is basically we want to make the chicken to be have the y-axis longer. That's why this is 1.1 float value. While the end position is about making the chicken goes one above at the y-axis too. That's why we do this +1. And then after that, well, this is actually now that I see it, I should make it into, no, actually this one good. So this is when we detect that the get button is up, but into up to the right, then it will make the position of the x-axis to be up by half. This one will, if it is going to the left, it will make the positions of x-axis negative to be subtracted by half, and so on and so forth. The up and so on. Everything is moved by half floating points. So this is basically about what you call it. This is about the directions of the jump, right? So when you press the button, right, you want the chicken to move, to jump to the right side. So not only the Y, but also the X or the Z, depending on which button you press. So that's what the jumping about. So the jumping is, if you see, it is at least make a three variable change. Three variable change. The scale, the y-axis, and either the x or z-axis. In summary, it will change two things, the scaling and the position of the object transform. Okay, so that's about the jump. Now let's go back. So we already talked about when the things that we need to do about when it is getting key button down, which is stuck down. When it's key button up, it goes to jump, and inside the jump, it will calculate the end position and the end scaling. While in the tuck down, we only care about the scaling. Now about the idle. So remember that when we go to tuck down and jump, we change the state of the chicken. If when the idea why we change the state of the chicken is because we want to ensure that it's not in the idle state, because otherwise it will be in idle state. If it is in idle state, this means also this state value I initialize it as the value idle. Okay. Now let's go back down. Let's see what is idle movement function about. Okay, so this idle movement, I make it so that it's having its own scaling speed. So it's of course the speed to jump and the speed to be idle are different. So in this case, I'm using 15 float because that's what I feel as good. Basically, the idle movement will check whether the scaling percentage and the position percentage is already completed from the previous decisions. Otherwise, it won't restart the calculations. If it is already 100%, it means whatever was the movement before has been finished. Now it can start to do the things. Because idle movement is actually also a repeated stuff. If nothing happened, the idle movement will be called again and again. Of course, we don't want to restart all the calculation again and again. We need to wait for the previous calculation to be fully updated, 100% updated. That's what the scale burst and the purge about. So when these two already 100%, we will do the calculation. This is the current scaling time. Of course, everything starts with 0. Same with the lerp time. Lerp time is about the position. And then we get the starting scale and starting position based on what the game object transform values are. And then if the start scale dot y is greater than 1f, start scale dot y greater than 1f, it means that it is in, it is in, what do you call that? It is in a position where it is enlarged, right? When it is enlarged, when that happens, we want the idle move, the next idle movement to be going down. That's why we make the scaling y here. The end scale will have 0.05 f float, and so with the position, because I make the animation, the chicken, actually I created it with Blender, and then I make the center of it is about the center. So when we actually trying to squeeze it down, the leg will go up. That's why the idle movement here, I make the Y position going down by a half because of that. That's the reason why I'm actually doing this negative 0.05 also at the y-axis position, not only about the scale. That's because of it, because of the center. Okay, so this is actually the things when we already enlarge the chicken, we want it to be going down. So basically when it is in the normal state, we want the chicken to be a little bit shortened. Otherwise means we already make the chicken shorten. When the chicken already shortened, we want to make it go back to normal. That's why we make the Y position to be 0F, to be in the back into the normal position at the verticals, right? Another thing is the end scale, we want to make it one scale back into the normal chicken scale. So that's basically the two conditions based on what is the current scaling value of the chicken. And that is idle movement. So it waits, in summary, it waits until 100%. It's starting up everything, then it's check whether it was already in if it was in the normal state, which is this one, then we will shorten it. Otherwise, we will revert it back to normal, revert the chicken back to normal. Okay, so that is about the idle state. Then how about this one? Actually, these sections, ready to idle and then change back to state idle, is best explained after we explain the update jump state. Now let's go, I think we already go talk about scale state, but let's just go again. Basically, this is just doing a factor tree alert to transform the local scale of our game object. Okay, of course we use the time delta, we adjust it with the scale speed here, and then if you remember just now, the jump scale speed and the idle movement scale speed are different, where the idle movement scale speed is like 3 times higher and so on. But that's basically about scale state. Then position state. Position state is the same, it's just that what we change is transform dot position, while in the scale cell we change the transform dot local scale. And we use the same factor tree and movement, which is factor tree lerp, linear movement. Okay, the idea is the same. We pass the start position, end position, and percentage of progression. And we use the lerp speed to control the speed based on the time happening. Okay, that's about position. Last is the jump set. This is the more interesting one because this is important for the jump itself. Okay, so when, let me adjust it so we can see the full writing about the jump state. So basically, when the previous movement has been completed, which is signified by that position percentage and scaling percentage is equal to 1, and the jump state is not equal to null, it means there it was not in the jump state yet. That's when we start everything here. Okay, so it will start with the current scale time. See, this is about the scaling part, preparing the scaling part. Of course, the timing, we start it again from 0. We grab the starting local scale of the game object, and then we calculate the end scale of the object, which in this case we want it to be back to normal, everything in one scale. While this is what happened with this update jump state, is actually it happened only when uh, we starting to jump. Remember that when we release the button, right? When we release the button, it will jump. The jump function was called, and the jump state is, and the state of the chicken become jump. Now this update jump state is actually to monitor when that first target of the jump already achieved. Because if you try to think about it, jumping is actually movement to two target point. The first target point, let's say if we move up, the first target point is going up and going forward. That's why if you notice, remember the jump function before only move forward by half, because the other half of the movement will be covered by this next target point. After the chicken already up in the air, it will then have to be updated to target into the next endpoint, which is going back to the earth to make the chicken goes down back. That's where the other half of the forward movement going to be happening. And this is what the update jump state is for. Remember, so once again, update jump state exists because jumping is about going through to target endpoint. The first jump is going to be up in the air. The second, once it's already up in the air, we will make it go back to earth. It is up in the air if the jump state is not equal to null. It is already fully to the air when all the percentage is goes to 1. Okay, so that's why the end scale is to move the chicken back into its normal scale, while the end position is about, if you notice here, it's using math max. We want it to go to 0, but we also want it to be gradually goes down by 2. So if we go up by 1, we go down, we go down 2 times faster. This is actually why I create this, is to make the flying experience, because it doesn't go directly to 0, but it goes by 2 as long as we press the up button, the button fast enough, the chicken shall fly. Okay, so it's like Flappy Bird, or if you play Nintendo before, it's like Megaman or Rockman. Depends on whether you are in Japan or America. I think they name it differently. Well, you know what I mean. And then this is just to check what was the jumping state, because if you remember, different arrow will go to different direction, and we need to know that direction. That's why it was saved before when we do the jump. That's what the jump state here for, to record what was the direction. And this, based on that direction, we know whether we need to do plus or minus into x or the z axis. That's basically what all this if for. At the end of it, when the end position, if we detect that the end position now for the y-axis is to 0, it means the chicken going to go back to earth. It means the chicken going to be ready to be in idle state. But why do I don't change it directly to idle state? The reason is because this update jump state is positioned at the end after we already scale up and down the previous target, right? It means when the end position first going to 0, it's not there yet. It's not there yet. That's why we should wait until at least one more update to make it back into the idle state. Okay, that's why we don't go directly to idle. Otherwise, this idle movement going to be starting while it's not yet go back to earth. That's the reason why we have this intermediate ready to idle, which is going to wait until all the percentage into hundreds or 1, and then it will then move back to the idle state. So that's it. That's how we make the chicken having a much smoother movement, much better control without any animation at all. So thank you for watching. Hope that is enjoyable for you. Please click the like button and subscribe if you want more like this. And put some comment if you have any kind of idea about what you want to learn more. Currently, I'm very interested with gaming. Cool. Thank you all. Maybe to before we close this, let's see the animation again, how the game works. So this is the chicken without animation, fully programmatic. And then the chicken can fly. Thank you all. Bye.